speaker. Please welcome Anna. Hello, Anna. Now, Anna, you teach yoga, don't you?
Yes, I do.
So I just thought, it'd be great if you could just teach us a bit of yoga.
Yes, I thought it would be nice if everyone stands up and we challenge our balance to be awake again. So, stand up.
Okay, I'm gonna get my camera ready because I've got a
Don't
feeling.
be shy. Stand up. We will fail here as well on the stage.
Yeah.
So, take a deep breath in and out. Then we will do the tree, you may know it. And for this, please put your right feet up and place it on your leg, but not on your knee. You can put it on the shin from the inside like this. Or put it a bit higher, but not on your knee. Try to get your knee right, one out. Stand, breathe. And maybe put your arms up.
Don't do the Macarena.
Come. Macarena, yes. Last. So you can put your feet back on the ground. Take another breath in. Deep breathe in. Deep out through the mouth, if you like. And we do it on the left side. So ground your right feet. Put your left feet up. Put it on your leg, not on the knee. Try to get your left knee out so that your hip is open. Please put your arms up. And Macarena.
Well, actually, pretty good, to be fair. Well done. Give yourselves a round of applause. You did that really well.
So, Anna, just wanted to check, how do you pronounce your surname?
Yeah, I think Anna is enough.
Well, everyone, big hand for Anna is enough.
So, thank you for the nice introduction. Today I want to tell you a little bit about static analysis and specifically Taint analysis. But before going into it, you have heard it already several times during GopherCon EU that we should start with stories. I want to start with something honest. I'm actually excited standing here, but also a bit scared. It's my first non-scientific conference where I'm standing on stage in person. And these slides also brings me back to my first Go conference I attended. It was back at the .go in Paris in 2016. And at this point I thought, no way, I will be standing on the stage. Look now, I'm standing and you already laughed. I made you laugh, so I think that's already pretty nice. And one of my thoughts was, which I was reminded yesterday during the social event and some of the breaks talking with others, that I asked myself, how the hell should I standing on the stage here if I wasn't even able to pronounce my name 20 years back? How should I tell to you something in a language not being my mother tongue? But one of the things changed is that I decided that maybe it's worth going out and fail, stand up and try it again. It's okay, for example, like in the exercise we did before. If you fail, if you're not steady, you try it again and you will become better. And one thing which is very important for me is also to enjoy it here as well, being on stage. And actually, one of the speakers, you will see later, he reminded me that I should enjoy staying here. So that's what I'm trying to do. But a little bit back to .go 2016. At this time, I was writing my master thesis, and it was about a Taint analysis. Not the one I'm talking about later, but the one you see on the slides, which is actually also my most successful GitHub project. I should work on my profile. But yes. at the one which brought me here. Jumping a bit into the future, at a brainstorming session with Angelika about potential talks I could give. And I saw a few Taint analyses coming up for Go shortly before. And she was like, yeah, that may be something being of interest for others. And here I am. You're listening to me now. And I hope you enjoy my talk as well. One other thing, while I was actually ill during one trial, thanks again for the chance and sorry, I gave one a week later and I already got the feedback that I used the tool. I hope the company is not the only one, and at least someone of you will also gain a little bit of listening to me. One big disclaimer. I'm not a maintainer of the tool I'm showing to you later, nor I'm using it at big scale yet, but maybe in the future, I don't know. But diving into the topic now, the motivation. So, with Taint analysis, you can find certain security vulnerabilities and problems. For example, if you log or log sensitive information like passwords, which shouldn't be logged, and these cause vulnerabilities, like the CVE you see in the top of the slide. There are also other vulnerabilities like SQL Injection. You may say, yeah, they are well known, we know them for several years, but actually, they still exist. And Taint analyses are also one tool, beside other analyses and code reviews you can use to detect these kind of problems. Now, I've talked about Taint analysis. You may ask, what the hell what's she talking about? I'm trying to give you a small definition of it. For this, I asked Ecothea. I'm actually using it before Jessica mentioned it. In the morning, I'm using it since, I think, 2012 or 13. And it's basically that we want to identify a flow of user input in our program through the system to understand potential security implications. So, like the two CVEs I've shown you one slide earlier. And want to check for malicious executions. For this, also I forgot to mention, we of course have to model the program somehow. That's what a static analysis is doing, without you having to execute your code. We all do this without execution. We do make assumptions about our code without executing it. Now, if you look at Taint analysis, there's a lot of terminology, and I want to demystify some of the terms for you. And the first one is sources. A source is a value that should be tracked. Looking at the example of the logging of sensitive information, it could be the password field and an authentication struct. The other field or name is things. Things are the instruction that should not be reached at all. So, for example, going back to the CVE mentioned before, our password should not reach a log statement. We don't want this to happen. These are the two fundamental terms you really often hear or read in the context of Taint analysis, and I will use them further now. There are two other important terms. The one is propagator. In programs, we sometimes pass values to other functions and process them. For Taint analysis, depending on your problem, a propagator is an instruction that modifies the source in a way that it's not relevant for your security problem. Looking at our authentication struct, it would be to simply return a string of the username and the password, but the password is still in plain text and not modified. A sanitizer, on the other hand, is an instruction or function that modifies the, your data such that it's not a security risk or a problem for your problem statement anymore. looking at our example from before, it could be simply to replace the password with 3 stars or something different. That's not enough. If you end up reading, for example, the README of the Go Flow Leeve tool, you also will hear something about pointer analysis and the static single assignment SSR analysis. These are basically the static analyses in the background that make assumptions of your program, that try to model the program for you and, for example, create a call graph. But actually, for your case or for this talk, you don't need to understand what it's doing. Just assume they're doing their magic, and you can rely on that. One problem of static analysis is also that we have to over-approximate the program. We have to make assumptions about the program before we run it, so we don't know everything which can happen. So especially if programs get larger, we need to over-approximate. That also means that we have to see false negatives and false positives. False positives are cases where the analysis is telling you that there is a problem, but if you as a developer who really knows the program and the domain says, no, that's not a problem here, you made a wrong assumption. On the other hand, we have false negatives. False negatives are cases when you inspect the program, you see that it's a problem, a security risk, for example, but the analysis is not telling you that it's a problem. That's quite a bit of theory for you, but let's go a little bit into taint analysis in Go. For this, I will start with 2 very short examples. You don't have to read and understand everything up there. So for the SQL injection, we basically have, for example, a source, which I simply called source, the function which may return the password. And we have a sink. In this case, I defined that for my program, the sink is the query to the database. And we are interested, can the source function reach the sink? The other example would be logging of sensitive information. For this example, I created a simple struct, which is called authentication. You also have seen it before in the definitions, where we have a username and a password, and of course our password is the source. And we have the function authenticate with a log statement, and we don't want our password to reach the log function, which is our sink. Now, you may ask me, okay, I understood the problem, but how can I actually use the analysis and make use of it? I tried to break down the rule of thumb of how to configure it for you. You have to identify the source types of your program, for example, the password field of your struct. And then you have to add the source types to your configuration, which is basically a YAML file. For this, you have the keys, package, type, and field. If you add RE at the end, you can also use regular expression, which may be really convenient to avoid a lot of boilerplate code, because it's just repetitions. Because we are looking at fields, you may know in Go you can also use field tags for fields of a struct, and you can configure these as well with the field tags, key, and value. Defining sources is not enough. We also have to define our sinks and sanitizers. For the sink, also your task is again to identify the sink for your program or your problem. And then add the sink functions to the configuration. For functions, we simply describe our function and the YAML file. Here you can define a package, receiver, and a method, and as before, add RE if you want to make use of a regular expression. You can omit the package if you want to match to any package which exists and have a method or a receiver of the method. If you omit the receiver, it matches to any or no receiver of the function. Now I just talked about sinks. For sanitizers, you have to follow the same recipe and just replace sinks with sanitizers and look for sanitizers functions. That was quite theoretical, but let's look at how we could configure it for the examples I have shown you before. I've defined two different types for the sources, as I have shown you before. Let's first look into the SQL injection. For the SQL injection, I define the type authentication in field password, and that matches now all packages that has a type authentication that has a field password, and these will be our sources. Looking into things, it's pretty straightforward. We identify the function query and define it as a sink. To show you something new, for the logging of sensitive information, I opted for showing you a concrete example for the field tags. Here I said the key should be data policy and the value should be a password. This, of course, requires most likely an update of your source code because you have to add the tags to your source code, like shown on the left. No, left, yes. I have a left-right mismatch all the time. And for things, it's also pretty forward with log and print. F, for example, because I didn't use the regular expression, but I think you know how to use them. Now, that was already quite a lot, and you say, I have used static analyzes before. They are total bullshit. They're producing so many false positives, I can't use them at all. And if that's your experience, there are also papers who confirms that it's one very frequent problem of the analyzers. And Go Flow Leeve thought, yeah, we are aware. We give you an option to tell us that we think there is a problem, but you say it's a false positive. You can achieve this with adding the command leave, do not report. And then Go Flow Leeve will not report this finding as a true positive anymore. If you do that, please verify all your paths in the program, because you may omit something, and the static analyzers try to see the complete program and all paths. And sometimes, at least that happened for me when looking into results, and sometimes just didn't saw one path for which the analysis was correct. Then I heard, and I think it's really a nice idea, that you also should inform others, if you add this command, why you think it's true, so that others can understand what you thought. And also from my experience, if you dig into code, 1 week later, you sometimes really don't know anymore why you think it was true or false. And because software evolves, you may want to recheck your assumptions from time to time. While I talked a lot about configuration, I will very shortly go on how to get it really running and actually running. For this, use the go install command and install Go Flow Leeve. Then you can use go wet and pass the Leeve to your configuration. You remember the YAML file we tried to configure before, and your project. And it will output you potential flows. But by telling you the concrete line and the field spacing where it thinks that a source has reached a sink, and also reports you exactly the line of code for your source. I think that's pretty convenient and kind of readable. Now, I think it would be unfair to not tell you a little bit about limitations. Sources can only be defined by fields and not methods. I had many uncaught exceptions that poisoned my output at the beginning, but in the end, the results were shown. I think that worked kind of enough. And there are still some flows that are not modeled at all. You can also check out Twitter to see thoughts of others on the tooling. I was asked on the static analysis channel on Slack on a short comparison to SamGrep. There I looked into it, and SamGrep is partly more mature and allows you more configurations, but it has one important drawback. It only allows you to analyze one Go file. And we have heard a lot about how to write good Go code. You can imagine Taint analysis looking only on one Go file, which is probably very small, is not the best idea. And here Go Flow Leeve can help you because they can look into your complete project and not only one file. With that being said, I want to end my talk. I've shown you that leaking of sensitive information and SQL injections are still a problem in 2022. I've shown you a short definition of a taint analysis where we want to track the user input through our programs directly to see if the user input can trigger malicious behavior. I've shown you that you can easily configure a YAML file for Go Flow Leeve to find potential flows for your specific problem, and that it can detect flows even through multiple files. That being said, thank you that you listened to my talk. I hope you learned a little bit about static analysis, and thank you for listening.